Hello, this is the Loomis Products 170-ton double tilt hydraulic piston extrusion press. The special Loomis double tilt design has a tilting press frame which can be set for any extrusion angle from horizontal to vertical. In addition, the material cylinder itself can be tilted another 90 degrees out of the press frame regardless of the press frame angle. This design allows you to load the material cylinder with your raw product in powder or paste form as well as in the form of full-length billets without changing the extrusion angle. Cleaning and servicing also become easier when the material cylinder is tilted out of the press frame. This particular model consists of the extrusion machine and power unit, allowing for either local or remote location. The power unit only requires the connection of three-phase electrical power and hydraulic hoses to the manifold located on the extrusion machine. The press operation is monitored and controlled using the latest technology in closed-loop programmable controllers, which are housed in a sealed enclosure located on the power unit. Let's take a look at the main components of the press. We have the main hydraulic cylinder, vacuum cap, piston ram on the front of the hydraulic cylinder, the material cylinder where the product's loaded. We have the die holder, and we have the operator console. Here we have the power unit. Notice the hydraulic valves. And the hydraulic connections. Vacuum pumping system. And the electrical control cabinet. Now I'll demonstrate the basic operation of the press, tilting the press frame and opening and closing the press. First I'll start with the hydraulics. Lower the press. Now I'll demonstrate the quick opening and closing of the extrusion press. Notice that the piston and the bearing cap move forward on the material cylinder in the closing sequence. Press is open for loading. material cylinder. This is the piston ram, and on this model, the piston ram is equipped with nylon on the face. This is the die holder assembly. The die is captured within the assembly on the inside for extrusion. It is easily loaded and unloaded through this hinged assembly. This is the operator console. It's equipped with a color touch screen and some push buttons for quick operation of power on, power off, forward and reverse in the piston ram, and an emergency stop. Within the touch screen we have setups, operations, a monitor for production, modes of operation, and the PLC-IO area. Within the setups, we can adjust the hydraulic pressures, the extrusion velocity, and the vacuum setups for evacuating the air from the material cylinder. Within the operations, it allows us to start and stop the hydraulic pump, start and stop the vacuum pump, cleaning mode, manipulation of the de-airing, press open and closed semi-automatic functions, and raising and lowering of the press frame in the material cylinder. The extrusion monitor provides a bar graph readout of the amount of material remaining in the cylinder for quick operator feedback, feedback of the settings for extrusion velocity and hydraulic pressure, as well as the vacuum timer and the step of the sequencer for automatic operation. The modes of operation are for the press, manual and automatic, and two different vacuum modes. PLC-IO area provides direct feedback of system status for maintenance and troubleshooting. This particular machine is equipped with a closed-loop control option. At the heart of this control option is a servo controller. This controller allows us to control the velocity of the piston to accuracies of within 1/1000th of an inch per second at increments of 1/1000th of an inch per second, providing precision extrusion control. This concludes our demonstration of the 170-ton piston extruder. Let's take a look at the main components of the press. We have the main hydraulic cylinder, vacuum cap, piston ram on the front of the hydraulic cylinder, the material cylinder where the product's loaded. We have the die holder, Can we have the operator, Don?